Hey everyone, it's Alfred.
It's Summerine.
Welcome to our live stream. This is episode 107, and in this episode we're going to be showing you how to do direction of arrival using the Matrix Creators microphones with a library called Odos. And basically Odos is this super powerful library that I believe a research student made and is currently still working on. He's doing his PhD thesis on it, and it lets you do a bunch of crazy things. It lets you visualize the microphones and where the source of audio is coming from, even like in 3D.
Yeah, we'll like take you over to the screen so you can actually take a look.
Yeah.
So Alfred, if you want to explain.
Yeah, so as you can see here, it's an open GitHub library. If you scroll at the to the top, or right at the bottom, I guess, in that paragraph, it says Odos stands for Open Embedded Audition System. And so it's a library dedicated to perform sound source localization, tracking, separation, and post-filtering. It's coded entirely in C, and it's optimized to run easily on low-cost embedded hardware, like a Raspberry Pi. So you can go on their GitHub page. Well, you can go to our link of our fork of their GitHub page, which is github.com/matrix-io/Odos. And then you can see, so here they have like a GUI, so you can visualize the sound, where it's coming from, the frequency of the sounds. And you can see, like, even you can see it in a 3D space, even though, like, for example, the Matrix Creator and Matrix Voice, they have 8 microphones, but they're on a single plane. But Odos is, so magical, I guess. Sophisticated, yeah. That it's able to show you even where audio is coming from above the device.
Yeah, and like this is super tough. Like you see this where it's like there's a 2D device and like there are particles that are kind of like where it thinks sound is coming from in 3D space. It's not easy. These algorithms are super tough. Like,
yeah.
Other than this dude, like, these kinds of algorithms, like, I mean, I'm sure they, like, obviously, like, people have them, but
the people who have them are like Amazon, Google, and those like huge companies. They don't open source these things.
Yeah,
so.
like somebody open sourcing such like complex, like, this is hard work.
Yeah, and it's optimized to run on a Pi.
Yeah.
So it's amazing. So basically what we're going to be showing you is we're going to be going through our Hackster guide for how to set up Odos on the Raspberry Pi with the Matrix Creator or Matrix Voice. We made config libraries for Odos so that you can specifically have it configured for your Matrix Creator or Matrix Voice. All the microphone measurements and directions are all done for you. So that's really easy. And then we're going to show you how to, as you're seeing on the screen, have LEDs indicate where the loudest sound is coming from, as well as a servo. So we have a couple 180-degree servos, so we'll show you how to make the servo turn to the direction that the sound is coming from.
Yeah, and like the fun thing about this is like, so this like direction of arrival using Odos, like one of our hardware engineers, Yoel, like figured it out with our Matrix, like made it compatible with our Matrix devices. But this kind of like shows you how you can build off of it, like add different components. Because if you know direction of sound, like where direction of sound is coming from, you can make a robot head turn towards it. You can make like a car drive towards it. Like once you have that like ability to like sense where the sound is coming from, you can react to it in any way you want, which is like the cool thing, which is kind of what we're trying to show.
Yeah. Or think of, let's say you're doing this as a security system for your home.
Yeah.
You can detect, okay, there is a sound, like a large, like, I don't know, high-pitched glass breaking like sound coming from where you already know the windows are. And then maybe it could get turn a camera to point in that direction. So there's a lot of things you can do with this.
Definitely,
like really cool.
So many applications. So all right, I guess we can like jump into the coding where we have a terminal that I have typed clear in, and you can see. Okay, so we will go down. So this is all like, it tells you what the required hardware is as usual. Tells you what ODAS is from like the GitHub description, and then it's basically a lot of copy pasting, as most of our guides go. Hopefully there will not be any roadblocks, but we shall see. So right now we're adding matrix repository and key, which is explain a little
So
bit?
basically, when you do like sudo apt-get update upgrade and then install eventually, it's telling it that okay, these are additional libraries to download, update, upgrade, so on.
Right, exactly. So now we are sudo update upgrading, and then when it comes to installing the matrix dependencies, you would do that one at a time because, and the reason for that is like during the process it'll ask you like, do you want to do this, yes or no, and like if you have another like sort of command queued up, it'll mess up because it won't realize what you mean. So this one should be quick because I had done it before. Alright, awesome.
Nice.
And then we will go to the one at a time. So matrix creator, init, it's like the initialization configuration, I think. The init
install?
one. Install.
Yeah, I think it's just, well...
Something like that.
Yeah, something like that.
Something like that. It's like an initialization. And then you're downloading HAL, which is our lowest abstraction layer in C++.
Oh, init. I thought you were referring to install as short for init.
Oh, no, yeah. We were
matrix
installing
creator init.
Yeah.
It's the initialization software needed to like flash the FPGA and set up the matrix creator's communication with the Raspberry Pi. That's what that is.
There we go. So that's stuff that I don't remember. Therefore, I turn to Alfred. Alright, sudo reboot. Cool. And then we will install the kernel module. So it's...
And the kernel modules are basically these modules that we have integrated right into the kernel of Raspbian Stretch, the OS that most people use on their Raspberry Pi, the one you can get from Raspberry Pi's website. And we've done that which to allow you to have use of like the microphones and all the other sensors from any possible thing that you could be running on the Raspberry Pi. Before this, you could only use some things just because some programs require like lower level access to things, and if the stuff isn't in the lower levels, they can't access it.
Right. So you need the kernel modules for mic stuff, right? Or...
yeah, for mic stuff mainly, yes. We have other things in the kernel modules, but they'll work out without them.
Right, so after installing the kernel modules, make sure to reboot. These reboot sequences are actually pretty important, so try not to miss them.
Yeah. And the Pis reboot so quickly nowadays that it's simple.
Super nice.
I had like the original Raspberry Pi years ago, and that thing would take like 2-3 minutes to turn on. It was so slow.
Dang, minutes. That,
yes,
like,
minutes.
I can't imagine
minutes. This
anymore.
is like 10-20 seconds max.
Yeah, I can't imagine minutes anymore. I would be so impatient.
Oh yeah, I was.
Like I feel like in 2 to 3 minutes, like with our like millennial mindset, we would like start doing something else and forget what we were doing.
Go on Snapchat, Twitter.
Yeah. So I'm just one at a time downloading the required dependencies. I think these dependencies are mainly for ODAS itself to work.
Yeah, those are all for ODAS. So G++, lib, FFTW3. I don't know what most
FFT, I think, is something to do with like this FFT is fast Fourier transform, right? So it's something to do with like the waves and like. So basically, when you're doing like signal processing and stuff like that, to like get the different frequencies of the waves, like to filter and stuff like that, you would use. It's a lot of math, basically.
I didn't know that. Okay.
Yeah.
Cool.
So
Learn something new every day.
So I guess I just did. Sometimes I forget what I copy pasted. Okay, so now I'm doing the lib.json. Okay. Okay, so
and if you're noticing, all these things are going super quickly because... Oh, you forgot the S.
Oh.
All these things are going super quickly because we've already done this. Like, we've already set it up on the Raspberry Pi. That way you don't have to be waiting for the video and for everything to install.
Yeah,
we're learning.
Exactly, yeah, exactly. So we just want to like do the, like go through the copy pasting, even though like, you know, it's pretty clear from the guide, just so that you would know kind of what order to do it in, things like that. So the reason it said fatal is because it actually has already been cloned. Don't worry, yours will clone, you'll be okay.
Yeah, and the commands Samreen ran there was change directory to the home directory, git clone, the repository, change directory to the Odos directory, which is what you cloned.
If I go back, so when you clone it, you'll be like here in the home directory, and you'll have a directory called Odos, so we're just going in there. And then once you do that, the git checkout, so the reason I'm writing this is because, so the add matrix demo is the branch right here. Let me highlight that. This branch right here is the one without the servo code, so I'm just gonna check out the branch with the servo code, which is servo matrix demo. I will show you guys the code and then like how you can change it for different servos, maybe to change the lights, things like that, so you know how to build off of these examples. So we're already on that branch, great.
And get checkout is switching to a different branch.
Yes, exactly. So like super nifty. So then mkdir build, that I'm not going to do because if you see, I already have a build directory made, and then cd build is going into it, so I'll do that. Cmake. So when you do cmake space ... it actually like for C++, it like creates all the make files. Or everything you need for like you know, building your C++ file, so I won't do that either. And then when you run make, basically it then compiles. So if I had changed any of these files, ODAS, ODAS server, ODAS live, matrix ODAS, then it would have rebuilt it so that I could actually run it. So now we've basically finished the, you know, the whole like installation and everything, so we're gonna run the demo. So as it says, we need 2 applications, so you need to run ODAS live in the background, and then run matrix ODAS, which is specifically like the LED responding to the ODAS server. So the way like this is kind of set up, so I'm gonna copy paste these. So the cd ODAS bin goes into the ODAS like home directory /ODAS /bin folder, where you have your matrix ODAS. Here, I can show you guys real quick. Like you have matrix ODAS, ODAS live, and ODAS server. So we're gonna do matrix ODAS / matrix ODAS, which runs matrix ODAS. Oh my god. And then the and, which I actually didn't know existed before I did this guide, basically lets you run another command during it. So
During it?
Yeah, so like you see, if I copy paste this, it'll actually accept it as a command. You know how normally when you run things, it doesn't accept it? So I took creator config because we're doing it on a creator right now, and we'll show you the creator in a second. So if I run it, it actually runs both. So super cool. So we will actually show you what we are seeing right now. So these are the angles, like just showing you real quick that they're changing. And here, let's adjust and change the camera. So here we have 2 of our favorite devices, a matrix voice, and a matrix creator. The creator is the one that we just did the program on, so that's the one that's running. So like as you can see, it's the arrow is, so I'm kind of talking from this direction, so it's kind of pointing towards my voice. So
and if I talk from this direction, it points to my voice.
But I want to be the one talking.
No, I want to be the one talking.
But listen to me.
No, me.
Alright, so we can like, you can, it's kind of probably funny to hear this because you can't see what direction the sound is coming from, but see the
know it because of this.
Yeah, so if I say, move my hand around here, blah, blah, blah.
Here, I can get a little broken trophy that we can just scratch on the table, so.
Pretty cool, right? So I mean, like, imagine if there was a robot head on here, and it was like looking at us as we were talking.
Oh, that'd be amazing.
Right? And then spoke back to us, like if it was like a fully integrated robot, like, you know, it would be super cool. So that's basically the demo that we want to show you. But now we'll come back to our screen so you can look at the code and how that's kind of working, and then how you can edit the code. So we have CyberDuck installed on our thing. So we spoke about CyberDuck, and actually I'll stop this because the sound is kind of annoying. I don't know if you guys can hear it. Then we'll also show it to you working on the voice because it works on both. And like all you would do differently for the voice is instead of copy pasting the for matrix creator use line as like after running matrix ODAS, you copy paste the matrix voice line.
And like I was talking about before, the reason why you're doing this is because we've created a specific configuration file for the matrix creator and for the matrix voice. And the reason why you need to do that is because the microphones on them are in different configurations. Like on the Creator, it's in a radial array of 8 microphones, versus on the Voice, it's a radial array of 7 microphones with 1 in the center. Plus, the distances between all the microphones are different. And so Odos needs the exact distances between all the microphones so that it can do all the math, calculating everything it's doing in order to tell where the sound's coming from.
Exactly. So we have used CyberDuck to SFTP into our, which basically enter into our Pi, and you see the Odos directory right here. We go in there. We want to go into demos. And then if you go into matrix demos, so there's a bunch of things. We won't touch the ODAS stuff because it's perfect. Matrix demos, and then matrix odas.cpp is the file to edit. So Control K, take me into Visual Studio, and here it is. So this, if you edit this, you can make
Can you increase the font size a little bit?
Good idea. Has the terminal been okay, do you think?
Yeah, the terminal's pretty fine.
So is it Command Plus?
I would think,
Okay.
yeah.
Okay. Cool.
Yeah, that's good.
Awesome. So
Better.
bye-bye. So let's see.
Control Option, right?
Control Option, right? I forgot. Haha, thank you.
Yeah, you don't have to worry. You don't have to.
Yeah, okay, it's fine.
Okay.
Yeah. Well, do you think we should show the terminal as well?
For now, no.
Okay,
Yeah.
Alright, so this is the matrix ODAS file. I'm not gonna go through everything line by line, but like just kind of go over the important stuff. So this interfaces with matrix GPIO. Basically, this library is what's enabling us to talk to the servos. So actually, I'm gonna put it to this side so you can see. Oh, here it is. Sorry. Okay. No. All right.
Oh no, you brought it over here.
All right. So Control
Option, left or right arrow.
Okay. Thank you. So anyway, shortcuts are lifesavers. And Alfred knowing shortcuts are lifesavers. All right, so if you go to our docs, so this is our docs. It looks squished because, but anyway.
We increased the font size, but you can go to it by going to docs.matrix.1.
And then, so we would go, after you go there, you would go into HAL, examples, and then GPIO to see like how that one's working. So here you have, you can, like using the library, you can do like other things as well, but there's a specific example for a servo. So that's super nice. I literally just copy pasted all the servo parts because I was like, I want to move a servo, right? So that's important. And after that, so this energy count, max value, all of these things are basically different variables that are holding like the amplitude essentially, or like how, like are keeping track of how loud or how strong, your sound is, right? And then, so this right here is just like, 1 or 0 GPIO input mode, again, GPIO stuff. The structure, I didn't get to clean it up too much, but anyway, so this is what, if you want to move a servo, and that's all you want to do, then you can use this file and adjust this little number here to change like whether the range of your servo maps properly to the actual angles that you're inputting. So for me, from trial and error a little bit, I found that 0.5 was a nice way for it to sweep from 0 to 180. It says if you're not sure of it, like in the docs, it'll say if you're not sure of it, try 0.8. So it's a good starting point. Then from there, if you make it like smaller, it'll have a larger range. And if you make the number larger, it'll have a smaller range. So it'll sweep less.
And the reason why you need to do this is because, servos are made by different manufacturers, different sizes, the boards inside of them are different, and then they could have different ranges. Some could be 90 degrees, 180, ours is 180, a 360-degree one, whatever. So this is just to configure it for your specific servo.
Yeah, exactly. So anyway, so these are just some variables that like I made to keep track of where the most like sound is coming from, and then turn the angle in that direction. So I'll go take you through like very lightly. Like the algorithm for the servo isn't that hard. The algorithm for the LEDs is like very cool. Yoel, one of our engineers, came up with it, and I was like, wow, as I was looking at it. So this is what Alfred was talking about, where if it's a matrix creator, these are like the angles of each of the LEDs in the matrix creator, kind of like hard-coded essentially, because ODAS needs those specific angles. And then, well, not ODAS, but like for us to, our program needs those specific angles to light up the appropriate LEDs, right? And then the same for the matrix voice. And then, so this like function right here is basically keeping track of the energy of like, basically what this is doing is keeping track of how like, yeah, the energy of the sound, say. And then decrease pots is basically making sure that like if sound is coming in from a direction, it's not just like a binary 1 or 0, it's like a wave. So it's basically like leveling it out nicely afterwards. If you like look into the nitty-gritty, you'll know why. And so the main part I wanted to talk about that I thought was like interesting. So the way ODAS works is I think when you run the ODAS like the line where it's like, oh, if it's a matrix creator, run this, like, so if you, when you do this part, right, it actually starts a server where ODAS data is being like is coming in. So like basically this is parsing the data it's getting from the server, which is like, so it's a JSON parse array. It's literally just going through that like message it's getting from the server, from the ODAS server, and that data has like the XYZ coordinates of the sound, or like, you know, it's not exact, but it's the XYZ coordinates of where ODAS thinks the sound is most likely to be coming from. And then it's giving you the energy of that, which means like kind of the amplitude in a way. So if you look right here, you can kind of see that. It's like, all right, he's storing the X coordinate, Y coordinate, Z coordinate, and then the energy. Yeah, so, and then, you know, this is like, I won't go into the nitty gritty. If you really want to know how it's working, if you look through the code, it's like, it's fairly obvious. So he's parsing the string. So in main, this is where everything is running. So, you know, he's initializing the ever loop bus so the LEDs can run, initializing the GPIO stuff, clearing the LEDs to start with, to set, you know, mode function, so that's for PWM and GPIO. And then this stuff like is like reading is like, you know, setting up the socket for the server client connection, right? So that's all of this stuff, all of this. And then the while loop is where all the fun happens. So this is where once it receives the message, it's parsing it, and then here in the for loop is where the LED fun is happening. So, you know, so this is where the config file, or no, not the config file, but this is where, like, depending on whether you said creator or voice, it knows to choose angles for the creator or angles for the voice, like, you know. And then if you have a creator, it'll make sure to use the angles for the creator. It's checking which angles generally have the most energy, and then basically setting the color course like in accordance to that. I don't know, but you get it.
If you have any questions about it, you can always ask us on our community. UL will respond. He made it, so he 100%
UL will be able
knows.
to explain better. I just learned, but what I think is cool about the way UL did it, though, is that for every single LED, he's setting the color, except for some of them, the color is 0, because there's barely any sound coming from there, you know? But like the ones where there's high energy, those are being set to like the brightest. But then if there's an LED, there's like a direction where you can kind of hear the sound, but not really, the LED will kind of be on, but it just won't be super bright. You know what I mean? So like that's why when you're talking from one direction, about like 3 or 4 LEDs will light up, but one of them will be the brightest, and that's the one that like is the pinpoint one. But it kind of still knows that there's sound around it.
Yeah,
you know,
it's kind of like a bell curve.
It's like a bell curve. So like that's super cool. It's not like, you know, just hard coded like this is the angle, because if you do that, then like it's super jumpy.
Yeah.
And the thing about this
like smooths it out.
And also using this, if 2 people are talking from 2 different directions, LEDs from both directions still light up. So, you know, it's a smart way to do it. So I thought that was pretty cool. And this is just the servo stuff I added. Super simple, right? So set servo angle. So this right here is just like a little kind of something to make sure the servo doesn't like kind of. So at first, when I just set the angle that I got from ODAS, so you're parsing. Let me show you real quick. Go up here. It's kind of confusing, but in increased pots, you can kind of see angle XY. So it's literally just you're taking. It's like trig, you know. So you have you're doing like tan of y over x, and then like arctan of y over x to get your angle, and then making it into converting into degrees instead of radians, right?
So that'll make sense if you paid attention in trig.
Yes. Yeah. So yeah, I'm not gonna draw the picture. I'm very tempted, but I won't. But anyway, so here basically, wow, it's been a while. I didn't expect this live stream to take a long. I guess I'm talking a lot. But anyway, here basically like it's right in here. It's basically keeping track of the max energy from like the and given like if so it's keeping track of the max energy and then setting the target servo angle to that LED angle because you want the servo to turn towards that LED, right?
Yeah. And since the servo doesn't have multiple LEDs, you're just trying to set it to the max one.
Exactly.
Unlike the LEDs where you want more of like a bell curve.
Exactly. So given that, then this little like thing here is, you know, this little chunk of code is just making it so that it doesn't like you know, like it's like actually slowly getting there. It's like incrementally, like it's incrementing it by 2, so the granularity is 2 right now. Incrementing it by 2 so it goes like a little slowly to where it needs to go instead of like just shooting to places. So it's like, and that's all. And then you just set the servo angle, printing the angle, and then resetting the max energy so when it goes through the for loop again for the next round, it gets the max energy again. So super simple. So if you wanted to have your servo do random things, you would write all the code in this region right here towards the end. If you wanted to add more servos, you would do it in this region right here. So like basically like everything you need to do is right here. So once like little thing I'll show you real quick, once you like edit your code, say for example right now it's doing blue and red, so it's purple, the LED. So if I want it to be just blue, just to show you like that it's working, I do Command S to save it. Great, it's been uploaded. Minimize that. And then to compile it, you go to CD ODAS build. So that's where you build your files, right? And you make, and it'll
make it.
Yeah. So then it'll make your C++, like it'll update the C++ executable. Go back to bin because that's where you have to run it from. And then literally just do this again. So matrix ODAS, I'll run that.
And switch the camera.
Then yeah, I will switch the camera. Good idea. Is it already pointing down? Alright, cool.
It is.
So I will now switch the camera so you can see the color of the LEDs will now be blue. Hello!
Hi! We're here with them. It's going up over there automatically because our computer's fan is loud.
Yeah, very loud. Anyway, so that was ODAS. And if you want to see it running on the voice as well, I'll kill the creator so it's not annoying with both of them. And then
They can compete.
run the one on the voice real quick so you can check that out.
Oh, and well, okay. Well, you're still looking down, but on the screen it showed that the name of the creator. So, see?
Yeah. Yeah. So since it's only 180, it'll only be like in this range. But if you have a 350 servo, then you could do it all around. That could be cool. You could have an owl. Alex, shout out.
Oh yeah, having like the owl turn its head.
Yeah. All right. So I guess that concludes it. Like we will go back here real quick and then.
Oh, wrong one.
Yeah, and then go back here. Cool.
Hi.
All right. So that was ODAS. Sorry that took a little bit longer. I thought it was going to take 15 minutes.
I told you it would have.
Yeah, but that was Matrix Creator Direction of Arrival with ODAS. So let us know your thoughts on the comments.
If you're watching right now, feel free to put a comment or, just write something in the live chat on YouTube or put a comment on Facebook. We'll check that for the next couple minutes. Until then, we have a couple of announcements. Yeah, so this is something, this one announcement is something that we've been working on for a while now.
Yeah.
We're really excited for it, and we're going to be launching it tomorrow, Friday, February 14th, December 2018.
Drum roll!
Yes. And what it is... kits! So we're going to be releasing Matrix Creator and Matrix Voice kits. We're going to have 4 of them available to start. A Matrix Creator kit, a Matrix Creator Computer Vision kit, Matrix Voice kit, and a Matrix Voice Computer Vision kit. And within each kit is the respective board, either a creator or a voice, a Raspberry Pi, some spacers, so I can take this out, and comes in this very nice box that we've made with custom foam, has a spacer for the creator so that it is attached, it's at the right angle, has an SD card already pre-flashed with Raspbian Stretch desktop with our libraries, Matrix HAL, Matrix Core, and the examples for them. And it has a power supply. So all you have to do when you buy one of these, you just, once it comes in the mail, get it, plug it in, and you can start programming it immediately.
Yeah.
It's plug and play.
Yeah. Plug and play.
So here, I can get the voice one too.
So you can check that out. But we're super excited about these kits. We've been working on them, and we really want people to be able to just plug and start programming. Get rid of the overhead.
Yeah. So. And this one, actually, you can see, has a Raspberry Pi camera. So the CV ones, computer vision, those all have a Raspberry Pi camera already put together with the nice spacers. And that's why there's a hole in the middle of the Matrix Voice or Matrix Creator for that camera. So yeah, you can just get this and plug it in, and you're good. By the way, the Matrix Voice that we're including in all of these is the ESP32 one. So that means that if you really want, you can, once flashed from the Raspberry Pi, you can use it standalone. You can take off the Matrix Voice from the Pi, and with the ESP32, which is a Wi-Fi Bluetooth microcontroller module, you can just run the Matrix Voice by itself. So yeah.
So super excited about that. Stay tuned. It's tomorrow, so it's not that long of a wait.
Yeah. It'll be sometime tomorrow, hopefully tomorrow morning.
Yeah, hopefully. But,
yeah.
Yeah, and so a couple other small things, in case you haven't noticed, well, you probably noticed if you've seen any of our other live streams, we just did a tutorial and no interview today. So we're trying out, kind of experimenting with the new format where we just have a standalone tutorial and then have a separate interview, speaking of which.
Yeah, and we're going to be basically alternating them. So 1 week we're going to do a tutorial, 1 week an interview, and that way it paces it out. It's not a super long video, and that way it's easier just to find, right? And next week, actually, will be our last live stream of the year. Yeah, and we will be interviewing Kitty. And that's her real name. It's amazing, and she's a super nice person. Yeah, she works at the Garage, Microsoft, in Microsoft's SF office. We met her back when we were at ARM TechCon in October, and basically, let me see, I have her card here.
She's a creative technologist, which I think is a super cool title.
And senior project manager. And basically, she, I believe, runs the Garage at Microsoft. And the Garage, it's essentially an incubator for Microsoft employees. So if they have any ideas or projects or whatever that they want to work on, they can go there. They have everything they need. And yeah, it's just a within Microsoft incubator. It's really cool.
And Kitty's super cool. I've seen a couple of things that she's been doing. She does a lot of designer clothes that have
wearables. Yeah.
That have cool LED sequences, things like that. And
dresses with lights all over.
Yeah, and so she really does a lot of cool stuff that I'm sure would love hearing about. So next week Monday. So
yes,
not too soon.
Yeah, not too late, far.
Not too far. Yeah. Yeah. So yeah.
Yeah, so that's it.
That's all,
so getting back to the kits, you'll be able to go on our website tomorrow in order to order them. Our website is matrix.one, O-N-E. And you can either go to the store page, which will be on the site tomorrow. Right now it's not yet. And it'll be like on the nav bar at the top. Or you can go to the education section on our website, where you can see how you can use a Matrix Creator, Matrix Voice in terms of education, whether you're a computer science student, mechanical engineering, systems, anything. It shows you like how it can be of use to you. And then from there, also, you can order the kits.
Mm-hmm.
So yeah, with that, I think that's it. Let's see if we had any like questions or whatever. Patricia or Patty.
Patricia.
Well, her name on here is Patricia.
Yeah, I know.
She's from our team.
Yeah.
She says excellent kit, and then let's check on the Facebook. Nothing on the Facebook.
Awesome. So I guess we can wrap it up. Like, feel free to leave comments in our YouTube. Always post on the community. The usual.
Yeah.
And thanks for watching.
Yeah. Thanks, guys. Bye.
Bye.